Hello class, welcome to our discussion once again. So we'll continue our topic on the chain rule for anti-differentiation. So we have already solved two problems. Initially we discussed the concept and then I give you two problem samples, and this time I will give you the third one. So our third example, we are given the integral of the square root of 4x plus 1 times dx. Okay, so that's the given problem. Now, as mentioned before, we have to transform this into this radical into a rational exponent, or an expression, algebraic expression with rational exponents, because now our given is an algebraic expression that contains radical. So we transform this into an algebraic expression that has rational exponents. So we can rewrite this as integral of 4x plus 1 raised to a power 1/2, or raised to an exponent 1/2 times dx. Okay, so we're still in the substitution process. So from here we can identify what is our n. Okay, so our n here is equal to 1/2, right? And then our n plus 1 is equal to 3/2. Okay, so that is 3/2, 3/2. Then after that, we identify what is our u. Okay, so we can have our u here, which is, we can let u be equal to 4x plus 1. Alright, so since we let u equal to 4x plus 1, meaning this one here, we let this one as our u. Alright, so we let this as our u. So therefore we can now rewrite the integral, or the given integral function, as integral of, so instead of 4x plus 1, we use u because we let that equal to u. Then you still use the same exponent, which is 1/2. Alright, and then we have to change this dx into something that contains du, so that we will have our new integral form as u to the n du. Okay, so where to get that dx equal to something that contains du? So that will be taken from here. So we let u equal to 4x plus 1. So when you take the derivative of u with respect to x equal to, so 4x, derivative of 4x simply equal to 4. Alright, so derivative of u with respect to x equal to 4, because derivative of 4x is 4, derivative of 1 is 0. Now, solving for du, so we can multiply both sides by dx, or simply cross multiply dx. So we have now du equal to 4 times dx. But what we need here is to find the value of dx in terms of du. Okay, so what is dx in terms of du? So that will be taken from this equation. Okay, so if you are going to divide both sides by 4, so du divided by 4, so this is equal to dx. Alright, so since we are looking for the value of dx in terms of du, and now we have solved it, and this is our dx, right? So this dx is just the same as this. So what is dx? Dx is equal to du over 4. So substituting it here, so instead of writing dx, we write its equivalent, which is du over 4. So times du over 4, or divided by 4. Okay? Then equals integral of u to the 1/2. We can rewrite this as 1/4 times du. Isn't it? Right? They are just the same. So this is a constant. Put this constant on the left side of the integral sign. So we have 1/4 times the integral of u to the 1/2 times du. Alright, so we are now in the general power formula form of the general power formula, which is integral of u to the n du. So this is equal to u to the n plus 1 divided by n plus 1, then plus c. Alright, so that is our formula. So we can use that. Sorry, it's not clear, so I will rewrite this. So our general power formula is the integral of u to the n du. If you can get this form out of your process, then you can use this formula. U to the n plus 1 divided by n plus 1, then plus c. Okay? So our form now here, the derived expression that we have after the substitution process, follows this form. So therefore we can use this formula. So our equation now becomes, our integral now becomes 1/4. So using the formula, what is u to the n plus 1? So 1/4 times u to the n plus 1, where our n plus 1 is 3 divided by 2. Okay, so 3 divided by 2 divided by 3 divided by 2, because this is also n plus 1, then plus c. I will just rewrite this 1/4 class now, because it's not really, just put it here. So 1/4 then equals here. Then from the rules of division of fractions, so we have here an expression, a fraction. So the rules in division of fractions is invert the divisor. Okay, so our divisor here is 3/2, so invert that, then proceed to multiplication. Okay, so we have 1 times 2 is 2, then we have 4 times 3 is 12. So 12 denominator, we have 2 at the numerator, so you can reduce that into lowest term. This can be written as 1/6 u to the power 3/2 plus c. Okay, then substituting the value of our u, so 1/6 times our u is equal to, this is our u, right? So our u is equal to that one. So substituting, we have 4x plus 1, then raised to a power 3/2, then plus c. So don't forget to write c. Okay, and in terms of radical, we must, although this is already correct class, that can be the answer, but we have to bring back the form similar to the given, which is in terms of radical. So how will you express this answer into radical? So 1/6, so we can write this as 4x plus 1, then cube, okay, cube. So this is the 3 here. Alright, this is denominator, the 2, that is square root. So put this in a radical like this, then plus c. Okay, and this is the same as, this is just the same as 1/6 times 4x plus 1 square root of this, and then raised to a power or exponent 3, then plus c. Okay, so either of these answers, okay, that one is already correct. But what I want to emphasize here is that you should know the different forms of this expression, because maybe in the examinations, if the exams are multiple choices, I mean the questioners have multiple choices, so at least you know. Perhaps if you know only this one, you don't know this, but in the choices you cannot see this, only either of these two, at least you know that this is just the same as this. Alright, so I think that's all, and thank you very much. If you have any question, you may send your question to our GC or comments, or send your comments to our channel. See you in the next video. Bye.